Guys, you may be wondering why I'm doing this particular activity in the bathroom. Well, I chose this because it's probably the brightest place in my house, and I thought it'd be easier to go ahead and demonstrate. So what you need for this is you need a piece of silverware. Okay, when you talk about silverware, it just needs to be metal, nice and reflective. The more reflective, the better. The other thing you'll need is a piece of tin foil. The fewer creases in it, the better as we go ahead and look at this activity. Now, one of the things I want to show you is as we go ahead and start looking down at the tin foil, it has a lot of light reflection. There's a lot of light bouncing off this. Now, as we go ahead and start looking at it in these smoother sections, one of the things that we notice is we get almost a nice clean reflection on it. And the reason for that is that the light is scattering off of it pretty uniformly. So when it hits it, remember, angle of incidence equals angle of reflection. And so what you're seeing here is that when the light rays come in, they hit, and they all hit at about the same angle, which means they all come out at about the same angle. Okay? But in areas like this, where there's a crease or a fold, you get light bouncing off in all different directions because the angle that they strike is not the same as the angle that they reflect. Okay, so the smoother this is, the closer we are to what's called a true reflection. You can kind of see a little bit of my phone here in the reflection. But in an area up here, it's not going to come back. It's more distorted because the light rays aren't coming in and going out in the same way. So if I take a section of this and I really crinkle it up, and then I go ahead and try and lay it back out again, if I can do this. Okay. You'll notice that while over here I can see my phone's shape here in the reflection, over here I can't, because again those light rays are coming in at so many different angles and bouncing out at so many different angles. Those are no longer coming back to the camera or to my eye. Okay, so when we start thinking about reflection, you have to realize that uniform reflection, like we see more in the mirror here, is done because it's so smooth that the light rays coming in come back out at the same angle, and that's when it reaches my eyes. And so then I can go ahead and perceive a very clear image. This is not polished at smooth, but if I were to get a metal polish, I could go ahead and actually polish this to a point where its reflection was really good. An area like this, though, is more like what you would see in a rest stop bathroom. You know, they have those kind of polished pieces of metal that it's not actually a traditional mirror, but it actually goes ahead and shows you your image just because of the reflection on a polished piece of metal. Okay, next thing, let's go ahead and move that aside for a second and switch to a spoon. Now, a spoon has two sides. It has the side that you hold the soup in and the side that you don't, the back side. Okay? Now, this is one of the best ways to go ahead and keep track of concave and convex. Now, if we're looking at the spoon, the side that you hold the soup in, okay, is the concave side. And the way I like to remember it is that you walk into a cave. This side, on the other side, that's not where the soup goes, on the back, is the convex side. This is the side that you can't go into. Okay, it's going to curve towards you. So concave on one side and convex on the other. Now, the next thing I wanted to talk to you about, and this is usually a demo I do in class, is I want you to go ahead and kind of take a look at the reflective image here. Let's see here. So as I look at the reflective image, okay, what do you notice about my image in the spoon? Hopefully you recognize that my image is upside down. Okay, so I know as I go out, the image is upside down. As I come in, my image is upside down. Okay? Now, that goes all the way in. Okay? All right. Now, when I go ahead and look at the other side, what do you notice? On the convex side of the spoon, my image is right side up. Okay? So as I go ahead and come forward, okay, that gets easier and easier and easier to see. Okay. Okay. Now again, that's convex. Concave, what did we notice? That my image is upside down. Okay. Now notice there's this little point right here where it kind of, it's really hard to film, but you'll notice that you'll start to see the image of the actual camera. Let's see, I don't know if I can catch it. Flips to the other side. There's a point where you get within a certain distance, okay? And this distance is called the focal length. So when you get inside the focal length, that image is actually going to flip to the other side, okay? So again, concave is this side that you walk into. Convex is the other side. When we look at a convex mirror, our image is upright, okay? When we look at a concave mirror, our image is going to be typically inverted depending on the distance that we look at. Now that'll be important next week when we go ahead and start looking at ray diagrams and how to go ahead and predict the enlargement as well as the position and whether or not the object is upright in a lens diagram. Okay, that works for lenses, it's going to work for mirrors, so we'll go ahead and talk a little bit more about how that works next week. So this week our main focus is on understanding reflection and refraction, what causes it, and making sure that we can go over Snell's law. Okay, so that's my demo for today, and I'll talk to you guys soon.